excited to talk to you a little bit about just some stuff I've been playing around with Docker and server-side rendering, what I've like to affectionately refer to as building a better mousetrap, and also an excuse to put cheese on a slide, I guess. So just a little bit about myself. My main day job is work as the principal UI architect for Clarivate Analytics and managing and running some open source projects of my own and a project around web components and just some things I've started up for myself. I like doing some music production and writing and retweeting a lot of other people's good stuff. I think the common thread between all of them, though, is that I really like helping people with technology, process, workflows, and just trying to make things a little bit easier during the day-to-day. And so I think that's the theme of this talk. It's not something per se that you'll install or download. It's hopefully something that you can take to your teams and try out if it applies to you. And I kind of like to capture it. And my goal is not to build the next best thing. My goal is to help you and your team build the next best thing. So, so today, what I'd like to go through is just a little overview of Docker and server-side rendering themselves. I'll dive a little deeper into what I mean by building a better mousetrap. Follow up with the case for containers, a little show and tell. That's kind of where I want to get most of my time in, if possible. Some next steps. I don't think we'll have time for Q&A through here, but I've got the green lanyard, so feel free to come up and chat about this or anything, really. I love, as my friend Paul knows, I love talking about code. So, so let's kind of jump into it. So just to get an idea, how many of you have or use Docker in your workflows, local production, all that stuff? Awesome, awesome. And have any of you had any experience with server-side rendering, like in like a single page application or? Okay, yeah, awesome. So good mix of stuff. So yeah, great. So just a quick overview of Docker. I think a lot of you probably understand it, but just to kind of walk through why I'm going to spend a lot of time talking about it in the context of server-side rendering is, so I think the best way to discuss Docker, I personally like to refer right to reference the logo itself, right? The little tiny squares are meant to represent shipping containers. And so the idea, the influence from the kind of shipping and freight industry was various sizes of freight need to be shipped around the world, rail, boat, train, whatever. And just like packing like a UPS truck, like, you want to get the most space out of it, but you want something standard, right? So every truck and boat and train can anticipate the same size container. What goes in it doesn't really matter, I mean, unless it's hazardous material, but the idea is you can standardize on the transportation mechanism. And that is really the heart of Docker as a tool. Instead of having servers that you would manage the OS, the version of Java or Node or whatever you're using, and moving away from servers as pets and more as servers as cattle, Docker, like the shipping containers, manages to encapsulate all the dependencies, runtime, the actual code for your application into something that you can essentially publish like an NPM package to a registry, pull it down to your server, and as long as your server is running the Docker process, that's the only contract you need. So operationally, development-wise, it's a very powerful tool. It certainly comes with its fair set of complexities, and but I think the learning curve is easy to get into in terms of just like, say, local development. But and essentially the Docker, this image that you publish is really just a set of instructions that you tell Docker to process. And that becomes the final state of this machine that you're going to start. And so just to illustrate that in the context of Node, for example, so in this case, we I think this illustrates one of the really nice features I like about Docker is this kind of extensibility. So in this case, on line 1, we're starting from a base image that that starts with node 8 and its various dependencies installed. And from that, we can now define this directory in the container where we can, within the context of our repository, grab our package.json, grab our source code, install our dependencies, expose a port, and then ultimately just run an npm script to start the whole thing. And so a Docker container is really just the running version of these set of instructions derived from the image that was published after Docker ran all these instructions. So Docker runs all these instructions, creates an image, you publish that, you pull down your image on your server, and you build a container from that. So an image is just a set of instructions to tell Docker how to run it. And so in this way, you can configure all sorts of different types of projects, languages, and again, the only common denominator that you need in your environment is Docker. So server-side rendering is, for everybody who's been doing web development for a while, in and of itself is nothing new. PHP is a great example of that, like Java server pages, things like that. So there's nothing new per se about server-side rendering. What is new, or what's been introduced into that kind of architecture, though, is single-page applications. And so the distinction with single-page applications popularized by React and Angular is that a lot of the heavy lifting is now done on the client side in the browser. The browser becomes the point of entry. You hit an index HTML file, you fetch some data, you render your list, and so the focus shifts back to the browser. The downside to single-page applications is that, in particular, search engine optimization is critical to the type of content you're delivering. You're now dependent on these Google search crawlers and Facebook crawlers to be able to execute your JavaScript, know what to do with it, maybe wait long enough for the response to come back. It's very inconsistent. So in the case where SEO is really important, but you still want to have a single-page application framework for a lot of the benefits that come with it, you start to run into some new challenges. And one of those main challenges is syncing state. So what I mean by that is, say you have a database, you're keeping track of the number of times people click a button. So when your server-side rendered app loads, you're going to pull that column from the database. Its value is going to be 3. You want to make sure that that 3 is rendered initially, like in the source of your initial response for your HTML. But you're going to, in the case of, say, a React app, you're going to have some sort of state too, right? So the issue you want to avoid is the user sees the number 3 that you pulled from the database on the initial load. If they click the plus button, if you haven't synced that data into the actual Redux state, when they click plus, they're going to expect to see 4, but if your default value is 0, they're going to see 1. So there's some challenges with it, but it's very popular, and it's a good strategy. It's kind of your only choice, though, if you want single-page applications with search engine. There's also a case to be made for performance, but I wouldn't necessarily start with server-side rendering just to do performance. And so just a quick example of a very simple kind of server-side rendering implementation. This example uses Express, popular web server framework written in Node. And so on this GET request to kind of the root of our server, we're just going to return a string. That's it. And the string just happens to contain HTML. And so I think from this, you could see where, after you import or require Express, you could require Mongo, make a call to your database, grab that value, and insert that value into the HTML you return. And that's some server-side rendering. So what do I mean by building a better mousetrap? So bringing together Docker and server-side rendering. I've worked on a few different projects that use Express.js a lot, and it never really kind of, I don't know, there's something about working on those projects, and it's going to be what I'm going to guide you through next, that always kind of stuck out to me. It was nothing major, but it still bothered me a little bit. So let me walk you through it and hopefully see if you can kind of see the process that I went through to get to this. Most of my experience has actually been with deploying Express apps into a Netflix stack. So when you need things like Zool and Eureka and maybe Kafka, it takes on a life of its own. And it can be just as equally complex as server-side rendering, but I thought server-side rendering made a pretty compelling example, and it's a lot easier to demo. So if we take this example of a basic React application, this is the package JSON for that application. In our dependencies, which are typically set aside for the code that you'll actually bundle in your client-side application, we would see what we would expect: React, React DOM, Redux. And similarly, we have our dev dependencies, and includes our build tools as we would expect, so Babel and Webpack and all those things. And so now if we want to introduce say a server-side rendering capability to our application, this is just a small sample of some of the dependencies we would want to add. Obviously Express, for PM2 for some process monitoring. In my case, the example I had was using some newer syntax, so we can install Babel Node. But the thing that kept me up at night is, where would I put those dependencies? They don't necessarily belong in the client side, but they're not necessarily like development dependencies, right? So I don't know, anybody want to take a guess? Where would you put these kind of an Express dependency in this package JSON? Yeah, that's what bothered me too. And so some might argue that, well, you're just kind of being pedantic. It doesn't really matter. You use imports to get your code. But it stuck with me. And then I happened to run across a server-side rendered project earlier in the year. And I don't know, maybe something just finally clicked. And I was finally able to actually describe to myself what was kind of bothered me about having to make that decision about where these dependencies go, as maybe trivial as it may be. And so really what kind of changed my thinking about it, without necessarily thinking of Docker first, was thinking of Express as not as a dependency, but as an actual runtime. And then with that in mind, it made a very seamless jump to Docker to provide this runtime that I felt didn't quite get captured as best as it could within the constraints of a package.json. So the case for containers. I just want to take this quick moment just to make the kind of disclaimer that Docker and server-side rendering are tools intended for a specific purpose. The motivation behind this kind of talk is not to necessarily say go out and Dockerize or SSR all your applications. But if the parallels to what you might be working on ring true to some of the points I'll make in the next slide, then yeah, it might make a lot of sense. But I just do want to caution that these tools do bring additional complexity. So it's important to understand, the cost of implementing them versus the value that they bring back. So I've been just, I was playing around. I've had some real world use cases, but we were already in a position where to jump to Docker was not hard. We had a full AWS-based deployments, so we're already in a microservices architecture of which Docker fits really, really nicely into. So why Docker? Well, the ability to basically package all your dependencies and your runtime and your code into essentially an artifact that you can publish and pull down is great. I mean, I think if anybody's used Java, the concept of wars and jars, you have a Tomcat server running, you compile your code, there's a single artifact, you drop that onto the server, give it a restart, off you go. It's a really nice operational workflow. And Docker, although it's not an artifact in that sense, it provides that similar workflow in that the image could be considered the artifact, although you still have to run it. It provides all the instructions needed to take this app that you've been working on locally with the operating system and the version of Node and your source code, and up it goes. And so because of this, it makes it's really nice for composability, like in the example where we started from Node version 8. This is a really nice way if you needed to standardize some of the operational steps in your organization, right? You wanted every application, because it needs to deploy into AWS, needs this base set of dependencies, this base set of configurations. And then on top of that, you want to layer on like a PHP app or a Python app, or in our case, an Express app. You have that sort of inheritance or extensibility model to do that. And it was important to me to make sure that the applications have bit of an escape hatch, right? As much as we want all our applications to be like cattle, there are going to be cases where you might need a post or pre-build step. And to not have some capability to do that could be a deal breaker, or at least something that's not already kind of intuitively available within the Docker workflow. You'll have to kind of break out of that. I think it makes a great local development tool, even if you're not deploying anything per se, or you're not deploying with Docker, but you want to have this very easy way to share an environment for people you're collaborating with across different operating systems, Windows, Linux, Mac. And so in this case where you might be doing server-side rendering, you might have some infrastructure in place, so Docker can make a really nice addition to that workflow. So I'd like to do a little show and tell here. So start with the code, just to kind of get everybody seeing what I've been able to see. Make that a little bit bigger. Okay. All right. So this is all available in GitHub. You can get the link through the slides that I uploaded as well. So this particular, and also this repository pretty much has a lot of the content that's already in the slides as well, so you can refer back to that. It's a little more narratively driven. So we could just start taking a quick look at the structure of this project. For anybody that's worked with front-end projects, it should look very familiar. You'd have your Webpack configuration, package.json. We have our source directory. This is a React application, so we have our components. In this case, we have our counter component that just has like the plus and minus buttons and allows you to increment in different ways. And we have our kind of app container here, and a little message to myself, which is part of the demonstration, and also these buttons, the counter component itself to increment and decrement. So this entire project is self-contained. It includes the Docker file and the server.js file in there. So those are the two things that I'll walk through because they're the two things that you probably wouldn't normally see in a strictly front-end project. But the first thing I want to do is I'm just going to run this in development mode. So I'm using Webpack Dev Server, and this will run this application, kind of the very traditional single-page application format. So here we have the counter, plus, minus. And like any single-page application, so we have this text here, this prompt to myself to check the source. But I'm going to just look in the DOM real quick. So, OK, so we have it, as far as the browser is concerned, yes, it knows about this text. But if we look in the source, so this is what was actually sent by the server, right? We don't see any of that text. We don't see any of the counter JSX. We don't see any of that dynamic content. And that's what a single page application is. It's all done on the client side. What you see in your browser is being generated after you get the initial payload from the server. So how did this become a server-side rendered application using Docker? Well, we'll look at the Docker file itself. So this was just added to the root of the project. In this particular case, I'm kind of starting from scratch a little bit. We're going to base our image on Ubuntu. I'm going to install Node 8. I'm going to add my dependencies for Express, and Babel, and some presets for my application. In my particular case, in this example, we're setting kind of the working directory on the container just to be the root. And we are, to app. But we are going to copy our code from our workspace. We're going to, in this case, we're going to install and build the entire source code within our on our host. And then we're going to copy our files from our host into the container in just the way that we want. So that includes the static output from Webpack, and our source code, because we kind of need, so this is the kind of the yin and yang to server-side rendering. You need code, you generally want your source code unbundled, available for that initial server render. But you also still need to have your kind of bundled application delivered to the browser so it can kick in after that initial payload, right? It's basically like a baton pass, right? The server gets the initial state set up, the initial DOM, and then it hands off to the client, says, OK, the counter starts at 3, put this in your Redux store, and now load your bundle and all that stuff. We're exposing the port, and then in this case, I'm using Babel Node, but we're going to use Babel Node and call our server.js. OK, and so in our server.js, we are importing React and Express. We are importing our app container, and this function called render to string, which is provided by React DOM. The part that I want to focus on right here is how we create this initial HTML. So we're using React components. If you've used Redux, the provider is the higher order component that you wrap your application in to centrally manage that state. And then in our case, we're passing in our store. We don't have any initials. If we have an initial state, like in this case, if we provide it from, say, the query string, it'll set that. Otherwise, it'll set it to 0. But this is important because if we were to pass in the initial state, yes, it'll get set to whatever that value is on the server side, but we also need to synchronize that so the Redux store that loads in the client can pick up whatever value that is. And so this is the kind of the expanded version from my initial slide. So this is what a more full-fledged server-side rendering implementation might look like. We can see here that we set a preloaded state to the window, and this is going to provide that communication mechanism between the server side and the client side. And we also still need to include our bundle as well. So it's very much a collaborative effort between the back end and the front end. So I'm not going to build the container just because of internet concerns, but what you can see here is, where are we? Yeah. So here's where I ran the Docker command. So this was in the root of the repository where the Docker file is. And we can see each step being executed. So from Ubuntu 16.04, we're installing dependencies, we're generating our Webpack build here, setting our working directory, copying our files over, and then ultimately, and then we end up with a pre-made image. And so now we can run this container. In this case, we're going to map our host port to the port that we defined in our Docker file. And now it says it started at 3001. OK. Looks the same, right? But now if we go to view the source, there it is. So this is a server-side rendered application that is generating the content dynamically and serving that. And so in this way, you'll have no issues with browsers and crawlers and the like. They don't have to wait for your JavaScript to parse now. They get it initially. And so and so in this way, we basically use Docker to, and so what we can do from this Docker file, where is it? A lot of this is, I did it for the context of this presentation where it's self-contained, but a lot of this stuff can become your base image, right? I mean, in theory, if your projects are all standardized, the only thing that is unique is what's inside this server.js. And so that's where your application can have that uniqueness to it to bootstrap itself. But meanwhile, keep everything the same. So you could have a Docker file that literally just is from your internal image, and it just needs to execute a server.js with maybe some predefined presets. And now anytime you need to make an update to your Docker file, you need to bump the version of Node, you can make the change in one place, and all your consuming applications just need to bump their version of the base image. So security fixes, improvements, like I said, a new version of Node, all that is not the responsibility of client-side developers anymore, or it doesn't have to be. And so just since we only have about a minute left here, I know that was a pretty quick, but again, I'm here for more questions. So this was some experimentation based on my experience, work experience, based on personal experience, and just my OCD tendencies, I guess. But where could we go from this? I would acknowledge that this implementation is definitely a little rough around the edges. That's kind of intentional because where I'd like to kind of fully demonstrate this kind of implementation is using a Docker compose file. And so this allows you, instead of having that kind of programmatic procedural set of instructions, you can use a YAML file and you can have this more declarative API-like interface, right? Where you, as the publisher of a Docker image, you can expose exactly what options you want to open up to your consumers. And so you could say, hey, tell me where your build output is, right? So you don't have to lock everybody in. Sometimes legacy projects, still want the benefits of containerization, but they might need a little help kind of getting over the edge. And so the configurability through this kind of compose API, I think is a lot more intuitive and also a lot more flexible. The idea of exposing hooks. So in the initial slide, we were just running npm start. That's an npm script. That command happens when the container starts. That's not part of the image. So you can have an opportunity to execute some extra commands for your application at start time. So not everything is baked into the image. And again, this is what I think makes Docker such a flexible tool, is you can abstract away the things that you don't want developers to have to worry about, like the operational overhead, but not lock them in so much that every change or every build step that they might have a unique case for has to be pushed back to like this base image, right? So it's just giving yourself enough wiggle room to get the benefit of the tools without being so locked in that you kind of feel like you're fighting against them. And so moving to this kind of compose API, I could actually publish something that's a lot more usable, like this repo could become an actual image in the Docker hub that you can consume. This would be, this format of a YAML file would be a lot more practical for that. And I'd really like to explore and provide more examples using other frameworks like Vue and Angular, and my personal preference lately using web components and more vanilla JavaScript. And so no time for questions on this stage, but as soon as I step off, I'd really love to talk to anybody who has any questions. And with that, thank you guys very much.